Okay, hello everyone. So this is probably my first video on a very new research topic, which is flexible or adaptive Droop control scheme in case of an MTDC system. Okay, so adaptive, flexible, dynamic Droop control scheme for VSC MTDC system. So I will explain you from the starting. I will give you some overview of what is VSC, what is MTDC system, what is HVDC system, what is Droop control scheme, what is adaptive or flexible or dynamic Droop control scheme. Okay, so I will be starting with a very simple things and then we will move gradually. So starting with the topic, which is HVDC system. Okay, so what do you mean by HVDC technology or HVDC system? So it stands for high voltage DC. So in our traditional transmission or distribution grids, in case of electrical, we see AC systems are being used. Okay, so for transmission, what we do, we elevate the voltage, means voltage is high. So in that case, current becomes lesser. In that case, I square R loss becomes lesser. So one of the reason of increasing the voltage is for minimizing the losses and effective transmissions. Okay, so similarly, recently transmission is being conducted not by using AC, but they are trying to shift from AC to DC. Okay, so if I define HVDC system, so it is the transmission of electrical energy over long distance by using DC over AC. So why do we need to transfer the electrical energy using DC only? Why we are shifting this? Why we are moving from AC to DC? So there are certain advantages. Okay, so the first one is cost of installation is lesser. Second one, losses are getting reduced. Okay, so losses are getting reduced. So what is do you mean by cost of installation is getting reduced? So in case of an AC transmission, you will see three phases: phase A, phase B, phase C. Okay, or we tell it as R, Y, or B. So in case of an AC, we require three different conductors for transmitting the electrical energy. But if we use DC, then we only require 2, which is the positive pole, and the second one is the negative pole. So here in this case, one of the conductor cost is getting reduced. Conductor cost is getting reduced. Okay. Similarly, in the terms of an losses, what do you mean? What are, first of all, what are the different losses that we face in case of an AC? Okay. So the first loss that we can say is I square R loss. Second one is the Ferranti effect, and the third one is the skin effect. Okay, so these are the mainly three types of losses that we can see in case of an AC transmission. But if we move to the DC, okay, if we move to the DC, then in that case, Ferranti effect as well as skin effect is getting cancelled. Correct? Because in case of skin effect, the tendency of the electric current is to move into the conductor is through the surface. It doesn't try to move through the inner part of the conductor. Okay, so it gives rise to more resistance at the surface and losses are increased. But in the case of an DC, there is no such effect for the transmission of the current within the line. So skin effect is getting reduced. Similarly, Ferranti effect is also getting reduced. Okay, this is the uh, overview of the HVDC system. What is HVDC system, why we are using HVDC system, as well as what is the advantage of moving from AC transmission system to DC transmission. Okay, now comes one topic which is known as VSC. So VSC stands for voltage source converters. Okay, VSC stands for voltage source converters. So you have known about other converters like LCC or line commuted converters, which is also LCC, which is line commuted converter, or we can say it as current source converters. Okay, so why we are not using current source converters or inverters in HVDC system, but we are using voltage source converter? So in the earlier times now, we used this LCC or current source converters within the HVDC system, but then we are making a transition from current source converters or inverters to voltage source converters. Why we are doing that, I will tell you. So first one, we can show it in the comparison way. So first one is the voltage source converters, second was is the current source converters. Okay, so in voltage source converters now, the electronic devices that we are used, it is IGBT, which is isolated gate bipolar transistors. But in case of current source converter, we used thyristors. Okay, in case of voltage source converter, it has the capability of bidirectional power flow, but in the case of current source converters or inverters, it is unidirectional. because current only flow from anode to cathode in case of current source converters, whereas in case of voltage source converter it has a configuration of PNPN type, where based on the uh, pulse width we can change the direction of the power flow easily. Okay, or we can change its output parameters. Okay, the third and the very most important factor because of which we are making the transition from current source converters or inverters to voltage source converters is because of independent control. So it is independent control of P and Q. But in the case of current source converters, P and Q can't be controlled independently, because changing one parameter affects the other. Okay, so I hope you know what is P and Q. P stands for active power and Q stands for reactive power. Okay, so to understand this topic now, mainly in this part, independent control of active and reactive power, this is a very important concept in the terms of voltage source converter. So if you go in the dynamic analysis or the derivation part for getting the P and Q, so you will get one equation which I will write it here. So when you derive the power flow equations for voltage source converters now, so you will get P is equals to 3 by 2 V into ID. Similarly, if you derive for Q, it is 3 by 2 V into IQ, where ID and IQ are the direct and quadrature access values. So why we are taking ID and IQ, not only I? So for understanding that, you need to understand the concept of three-phase rotational phasors for current, like IA, IB, IC, and why we are moving it to two-dimensional or two parameters division, which is ID and IQ. So we cannot make any analysis when the phasors are moving at some angular speed, okay, omega r. So we need to make that static. So for that part only, we are get like converting the phasor value of IA, IB, IC in ID and IQ, where ID and IQ are they are not like moving at any particular value of angular speed. Okay, so if you study about the dynamic control scheme or the dynamic analysis for voltage source converters, you will get to know all these things. Okay, so I will give you just the basic things for understanding the topic. Okay, so what are the major important factors that makes us the transition from traditional electronic methods to the current or the voltage source converters method, is because the independent control of active and reactive power, that is one of the, and the other is the capability of bidirectional power flow. Okay, moving to the next, I will give you one schematic diagram or a simple example of an HVDC system, how an HVDC system looks. So basically, HVDC system in earlier times means only have two terminals, where this is converter number 1. This is a DC bus. We make the transmission. We have another converter number 2. We have another bus, and this is another AC. So we can say it is an AC grid 1. This is AC bus 1. This is converter. This is DC transmission. Sorry for my handwriting. This is converter number 2. This is an AC bus 2, and this is AC grid 2. Okay, so HVDC system means transmission of DC over the long distances. So this is what we are doing. We are first converting the power from AC grid 1 into DC. So here, what is the conversion from AC to DC? Here DC is getting transmitted, and in this converter we are making the conversion from DC to again AC, and which is being used by the AC grid number 2. Correct? So here what we are doing, we are transmitting the AC energy, AC electrical energy, from one location to the another location. Okay, so why we are doing this? One question you might ask, what is the importance, or why we are making this transmission over the DC only? So the three important advantages I have also mentioned you in the earlier, but there are again two more advantages why we are doing that. Okay, so this is the main one, advantages. First one, I will write what is the advantage. You won't understand it the first. I will explain you, which will make your thing easier. Okay, so the first one is asynchronous integration of different grids. This is the first point. You won't understand what do you mean by asynchronous integration of different grid. And the third one is integration of renewable energy resource.